Because it has anomalies. It moves on a trajectory that is very unusual, is aligned with the orbit of the Earth around the Sun, and it will get extremely close to the inner planets like, for example, Jupiter, Mars, or Venus. It will arrive closest to the Sun when the Earth is on the opposite side, so we won't be able to look at it. You know, the chance of this trajectory is less than 0.2% to be aligned with the orbit of the Earth around the Sun, less than 1 part in 20,000 to arrive so close to the other planets. And one wonders, could it be a design trajectory?
Something just entered our solar system from deep interstellar space. It's not a comet, it's not an asteroid, it's moving backwards, perfectly aligned with our planets. James Webb recorded it, and then NASA locked the data. No explanation, no images. If there's nothing to hide, why the silence? In early 2024, astronomers detected a strange object entering our solar system. It was fast, dark, and coming from beyond the reach of our sun's gravity. Almost immediately, it was classified as an interstellar visitor, the third ever recorded by humanity. Its name, 3I Atlas. Unlike anything we've seen before, this object was caught early enough to study in real time. And for the first time ever, we had a tool capable of capturing it in detail, the James Webb Space Telescope, the most advanced space observatory ever built, capable of peering deep into the infrared spectrum, revealing the chemical fingerprints of distant stars, galaxies, and now, a rogue traveler from another star. Webb aimed its massive eye at 3I Atlas. It recorded over 40 gigabytes of high-resolution spectral data. But then, something unexpected happened. Nothing. No press release. No public images. No shared results. The data was immediately sealed, locked behind a scientific embargo that only the original observing team could access. For months, no one outside that circle would be allowed to see what James Webb had captured, and that's where the mystery begins. Why the secrecy? This wasn't just a star-forming region 10 billion light-years away. This object was here, now passing through our system, never to return. And yet, we were told to wait. Wait for the data. Wait for the paper. Wait for the silence to break. But what if it never does? Most people think the James Webb Space Telescope is controlled entirely by NASA, but that's not exactly true. While NASA helped fund and launch it, the actual operations are handled by a private research institute, the Space Telescope Science Institute, or STSCI. And here's where it gets complicated. Webb is a publicly funded telescope, but access to its data isn't truly public, at least not at first. Scientists and institutions around the world submit detailed proposals to use Webb. These are competitive, technical, and reviewed by committees behind closed doors. If approved, the team gets exclusive access to their observations, sometimes for up to 12 months. This period is called a data embargo. During that time, the data is essentially locked. Only the original researchers can view or analyze it. No one else, not even other scientists, can access it until the embargo expires. Not unless the original team decides to release it early. Now, in most cases, this process makes sense. Scientists want time to study their findings before others publish on them. It protects academic credit. But with 3I Atlas, that logic starts to break down. This isn't a distant star system or a remote black hole. This is a visitor inside our own solar system. It's only here for a short time, and then it's gone forever. So the question becomes, why keep that kind of discovery under wraps? Why lock the data from the public? What's so sensitive about 3I Atlas that it can't be shared? Was it just bureaucracy, scientific competition, or did they see something they weren't ready to explain? The team that first observed 3I Atlas through the James Webb Space Telescope was led by astrophysicist Martin Cordner. Their proposal was approved. They captured a complete spectral cube, an incredibly detailed dataset that shows how the object reflects and absorbs light across different wavelengths. Over 40 gigabytes of raw infrared data. That's enough to tell us about its chemical composition, surface material, maybe even its origin. And yet, they didn't release it. Instead, they activated a minimum 3-month embargo, locking the data for their own analysis. No early release, no open access, just silence. Here's the twist. At the same time, a second team, led by Matthew Pellico, submitted a separate request to observe 3I Atlas using director's discretionary time, a fast-track system meant for urgent or unusual observations. They looked at the same object, with the same telescope, and their data made public immediately. Same object, same window of observation. 2 teams, 2 decisions. So, what's the difference? Why would one team choose secrecy while the other chose transparency? What did Cordner's group see in their data that the other team didn't? Was it just about claiming academic credit first? Or was it something deeper, something unusual, hidden in the infrared spectrum that they're still trying to understand? Or worse, something they're trying to control? Let's talk about the way 3I Atlas moves, because it defies almost every expectation we have for an interstellar object. Most objects that enter our solar system from deep space do so at steep, chaotic angles. They're thrown by the gravity of distant stars, flung across the galaxy like cosmic debris. They come in hot, unpredictable, and fast, on paths that slice through the solar system before vanishing forever. But 3I Atlas doesn't behave that way. First, it's moving retrograde, traveling in the opposite direction of our planet's orbit. Only a tiny fraction of known objects do this. It's rare, and it requires more energy, which usually means unnatural. Second, its orbit is almost perfectly aligned with the ecliptic, the flat plane in which all major planets orbit the Sun. Earth, Mars, Jupiter, even the asteroid belt, they all move along this same invisible track. And 3I Atlas is just 5 degrees off that plane. That level of alignment is statistically bizarre. Interstellar objects are supposed to be random, but this one came in like it had a plan. Then comes the real kicker. As it entered the solar system, 3I Atlas passed by 3 planets, Mars, Venus, and Jupiter, in that exact order, not by accident, not barely missing them. It flew within proximity to all 3. That kind of sequence is rare. Not only is it gravitationally unlikely, it's backwards from the natural flow of the solar system. Instead of falling inward toward the Sun, as gravity would dictate, it appears to move against the natural current, as if it's navigating. Mars, the red desert. Venus, the toxic furnace. Jupiter, the giant of storms and gas. 3 planetary extremes, one after the other. And 3I Atlas flew by all of them, almost like it was scanning. So now the question becomes, is this an object following physics, or a probe following instructions? When it comes to interstellar mysteries, one name always rises to the surface: Avi Loeb. A tenured astrophysicist at Harvard, Loeb has become one of the most polarizing figures in modern science. He's brilliant, respected, and fearless when it comes to asking the questions most scientists are too cautious to raise in public. In 2018, he made headlines around the world when he suggested that Oumuamua, the first interstellar object ever detected, might not have been a natural rock, but something artificial, a probe, a device, a messenger. His theory sparked outrage, fascination, and a global debate. But Loeb never backed down. Now he's watching 3I Atlas, and once again, He sees something most people are choosing to ignore. He's not just guessing, he's done the math. Loeb calculated the odds of an interstellar object entering our solar system with the trajectory Atlas is following: retrograde motion, a near-perfect alignment with the ecliptic, and a path that brushes past not one but 3 major planets. The result? A probability of roughly 1 in 20,000. That doesn't mean impossible, but it means deeply unusual, statistically rare enough that it demands attention. For Loeb, this isn't just an anomaly, it's a potential signal. He argues that when we see objects behaving in ways that nature rarely produces, we have to consider the possibility, however uncomfortable, that we might be looking at something deliberate. He's careful with his words, never shouting aliens into the void, but he does challenge the assumption that everything unfamiliar must be natural. Maybe we've spent too long assuming the universe is quiet, when in reality, it might just be speaking a different language. 3I Atlas moves like it knows where it's going. Its velocity is fast enough to escape the sun, but not so fast that we couldn't track it. Its path isn't chaotic. It's smooth, calculated, efficient. For Loeb, it's not just the physical properties of the object, it's the pattern behind them that matters, because patterns imply structure, and structure implies intent. Is it a probe, a scanner, a drifting remnant of someone else's technology? Or is it just a very lucky, very strange piece of rock following a gravity-assisted route? Loeb doesn't claim to know the answer, but he insists we ask the question, because refusing to ask, that's the real danger. He believes that the search for extraterrestrial intelligence shouldn't begin with fantasy. It should begin with evidence. And maybe, just maybe, 3I Atlas is evidence. If that's true, then what we're witnessing isn't just a passing object, it's a missed opportunity, a message encoded in motion, and the longer we dismiss it, the more we risk never understanding who or what might have sent it. This isn't happening in isolation. 3I Atlas is the third confirmed interstellar object we've detected in less than a decade. Before 2017, we had never seen one, not even once. And then suddenly, a pattern. First came Oumuamua in 2017. It had no visible tail, no cometary outgassing, no rotation pattern that made sense. Its shape, likely flat and elongated, more like a solar sail than a rock. It accelerated as it exited the solar system. No one could explain it. Then in 2019, we detected 2I Borisov. It behaved more like a traditional comet, but it was chemically unlike anything seen in our solar system, heavier in carbon monoxide and cyanide than expected. It came fast, it left faster, and now 3I Atlas, different again, but like the others, it showed up quietly. It caught us off guard, and it will be gone soon. 3 interstellar visitors in just 8 years. After centuries of silence. Coincidence? Or are we entering a new region of the galaxy, one where strange things drift closer? What if these aren't just random objects on random paths? What if they're connected? Same general corridor, same unexpected characteristics, same reluctance to release data publicly. Each one gets stranger, each one appears, gives us a glimpse, and vanishes. And just like that, we're left wondering what we missed, because here's the truth. A comet is random, debris is chaotic, but this feels like a pattern, and when the universe starts repeating itself, it's time to start asking why. Just when things are getting good, when the object is approaching its most revealing moment, we're about to lose it. 3I Atlas is moving fast. In late October, it will reach perihelion, the closest point in its journey to the sun. That's when things start to change. The heat will trigger outgassing, causing the object to shed dust, ice, and gas. This isn't just a visual phenomenon, it's a scientific opportunity. As material escapes the surface, it reveals what the object is truly made of. It's like seeing beneath the skin of something that came from another star system. The composition, the chemistry, the thermal behavior. This is the moment when the object could tell us everything. But we won't be watching, because just as it reaches that critical point, 3I Atlas will be positioned directly behind the Sun from Earth's perspective. From the ground, telescopes will be blinded by the solar glare. Hubble, orbiting Earth, won't be able to see through the brightness either. Even James Webb, which sits nearly 1 million miles from Earth, has strict safety protocols to avoid aiming its instruments near the Sun. It simply won't be allowed to look in that direction. The timing couldn't be worse. We wait decades, lifetimes even, for an object like this. We finally get one close enough, active enough, mysterious enough to study in detail. And just when the story reaches its climax, the curtain drops. A perfect cosmic blackout. By the time 3I Atlas reemerges from behind the Sun, it'll already be on its way out, cooling down, fading, slipping into deep space forever, and we'll be left staring at empty sky, wondering what we missed. There are no replays in astronomy, no second chances. The universe moves forward, and if we blink at the wrong moment, we lose everything. Just when it seems like 3I Atlas will slip through our fingers, there's a glimmer of hope. 2 spacecraft, both already out there in the vastness of space, are moving along trajectories that bring them unexpectedly close to the object. One is NASA's Psyche mission, currently en route to a metal-rich asteroid between Mars and Jupiter. The other is ESA's JUICE, on a long journey to explore the icy moons of Jupiter. Neither of these missions was designed to study interstellar objects. Their instruments weren't calibrated for it, and their fuel budgets are razor-thin, planned out years in advance. But in a twist of cosmic alignment, both spacecraft are expected to pass within just a few dozen million kilometers of 3I Atlas, close enough to potentially observe it during its peak activity near the Sun. Not close enough to intercept, but possibly close enough to gather readings that no other observatory will be able to get. The opportunity is there, but the risk is real. To observe Atlas, both spacecraft would need to burn fuel, divert from planned trajectories, and reprogram onboard systems, moves that could jeopardize years of planning, funding, and mission success. In deep space, every maneuver is a gamble. Every gram of propellant matters, and mission managers are notoriously conservative when it comes to taking detours. So the question becomes, is it worth it? Is a fleeting encounter with a mysterious object from another star worth rewriting flight plans and risking billions in equipment? That decision now rests in the hands of engineers, administrators, and scientists who may not even believe this object is worth the trouble. But what if it is? What if this is the only shot we'll ever have to observe an interstellar object from such close range, not from Earth, not from orbit, but from within the same region of space? What if just this once we caught something incredible and let it go? When every telescope fails, when spacecraft drift past without looking, there's still one last idea, one last desperate shot in the dark. A few researchers have proposed something radical, almost unthinkable. What if we used an existing spacecraft, one already deep in the outer solar system, to intercept 3I Atlas before it vanishes forever? That spacecraft is Juno. Juno was launched in 2011. It's currently orbiting Jupiter, studying the gas giant's atmosphere, magnetosphere, and mysterious core. But it's nearing the end of its mission. Its main engine is damaged, its fuel reserves are limited, its systems are aging, and it was never, ever intended to chase down an object moving at nearly 60 kilometers per second. But still, the math is there. With a perfectly timed gravity assist, maybe one last boost from Jupiter's immense pull, it might be possible to send Juno on a new trajectory, one that could bring it close enough to 3I Atlas for a brief encounter in 2026. Just imagine it. A spacecraft that was built to study Jupiter, suddenly reprogrammed to intercept a visitor from another star. A final mission, one last maneuver, a first in human history. But there's a reason this hasn't happened. The risks are enormous. The navigation would have to be flawless. Any error, any miscalculation, and Juno could veer into deep space with no way home. And there's no guarantee it could capture useful data even if it reached the object. Its instruments weren't designed for this. Its sensors might not even function in the required orientation. To most scientists and engineers, it's a fantasy. Too dangerous, too late, too costly. But there's another way to look at it. What if this is the only opportunity we'll ever get to study something like this up close? Not from afar, not from blurry images taken through atmospheric distortion, but from within the object's own shadow, seeing it, sensing it, almost touching it. What if, for once, we took the risk? Because if we don't, 3I Atlas will disappear into the void, unstudied, unexplained, unresolved, just another ghost from another star. And once it's gone, it's gone. 3I Atlas is real. It's out there right now, cutting through the solar system on a hyperbolic path, one that will never bring it back. It's moving at nearly 60 kilometers per second, fast enough to escape the pull of the sun entirely. And as you watch this, it's already disappearing. The chances we had to study it are closing. The windows we thought we'd use are now gone. And the most advanced telescope we've ever built, James Webb, saw it, recorded it, and then sealed the data away. We're told it's just standard protocol, that scientists need time to analyze, to publish, that there's nothing to worry about. But this isn't some far-off quasar or star-forming nebula 10 billion light-years away. This is something here, now, inside our solar system, a traveler from another star. And we chose silence. Maybe it's just a rock, just another frozen relic from a distant corner of the galaxy. But maybe it's not. Maybe there's a reason for its trajectory, its alignment, its sequence of planetary flybys. Maybe someone or something sent it. And if that's true, then this isn't just science. It's a message, not one we can read. Not yet, but maybe one meant to be seen, or heard, or followed. Because this isn't just about 3I Atlas, this is about what comes next, about what else might be out there, about what's already passed us by, unnoticed, and what could be on its way right now. We used to believe the universe was quiet, predictable, cold, but that illusion is fading, and what's left behind is a growing sense that we're not alone. So ask yourself, if this wasn't a cover-up, why does it feel like one? And if the sky really is silent, why do they keep telling us not to listen? This may be the end of the story for 3I Atlas, but it's not the end of the mystery, because what's coming next changes everything. So if you think this was strange, you have no idea what's waiting for you in the next chapter. Click here and don't blink.